This is Integrated 3, and this is going to be our first review section, and we're going to talk about what a function is. So in this lesson, we're going to define what a relation is, define what a function is, state whether that relation is a function, and go over the domain and range of a function. So first, let's get into what we're talking about as a relation. So by definition, a relation is where you have an x-coordinate and it's matched to a y-coordinate. Or it technically could be anything. You could match anything to another. We could say we're going to compare shoes to height. We're going to compare the type of person to the type of food. You could technically compare any two things together, and that creates a relation. Now, there's a special type of relation, and that special type of relation is just saying that for every x-coordinate that you have, there is only one y-coordinate that can describe it. And if you notice, this is blue. One thing I want to talk about is if something's in blue, it's a good idea to write it down. It's important information. Gold means definitively this has to be memorized. If you memorize these things, you're going to be golden. So that's why it's going to be gold. So by definition, we want to get this round. A relation in which each x-coordinate is matched with only one y-coordinate is said to describe y as a function of x. So when we describe it that way, we could say that it's going to be a function, and we have special function notation in which we can go ahead and write it as such. Now, when we have any type of function, we like to say that our domain is going to be the set of inputs, and the range is going to be the set of outputs, meaning that the input is what we select for x, or the possible values that we can select for x. And then the output is once you take those x values and put them in, what are we getting from it? So it's like a weird analogy, but think of it as like a juicer. The input, it would be the orange, the output would be the juice. What do you get from it once you plug something in? And like I said, the values that we can plug in are typically the values that could naturally exist in the function. And if you're thinking to yourself, well, what does that mean? Well, if we have a function in which if you plug something in, you get undefined, that can't be part of our domain because you got an undefined value. So technically, it's everything except those values that would make it undefined. Now, this is a way for us to write if it's a function or not. We use this f of x notation, and we call the x the independent variable because it's variables that just exist naturally. And then the y values, we call it the dependent variable because the only way you can get it is with the x. So the y value is dependent on the x value that we choose. So let's look at a few functions, and we're going to look at them graphically and analytically here. So the question is, in this example, is this going to be a function? And we, like I said in the definition, we said that for the x value, there can only be one y value. And so this x value has 5, this x value has 2, this x value has 0. Okay, so here's the red flag. Right here, my one x value, x, or -1, has two different y values. It has 5 and it has 0. So therefore, it is not a function because my one x value could have two different y values. Now the same thing here. My one x value of 2 could have these two different y values of 7, and so therefore it's not going to be a function. Now let's take a look at this graphically. And so I'm going to take these values here and I'm going to put them on a graph. So graphing these, is this going to be a function? Well, we can do something called the vertical line test. And what we do, and this is only visually, right? I could take a look at this and be like, oh, well, here at 1, I have two different y values. It's matched to 3 and it's matched to 4. There's not a single value for x here that is matched to another different y value. So technically not a function, and this one is a function. But if we use this vertical line test, basically what we do is we draw an infinite number of these vertical lines. Imagine if we were to draw an infinite number. Now, if we can find one case where that imaginary vertical line passes through two values, it is not a function. So in this instance, in this first one, just by this vertical line that I drew here, I know it fails the vertical line test, and therefore it's not a function, versus this one, if I were to draw an infinite number of these, it passes that vertical line test every single time. Let's look at another example here. So if I were to use the vertical line test, so if I were to draw in that imaginary line, it's going to fail, therefore it's not a function. And on this next one, there's not a single vertical line that I can draw that will make it pass through two values, so therefore it is a function. On here, once again, this would make it fail because there's two values there, but because this one has an open circle, it actually passes because it crosses through the first one, but because there's no point in that second one, it's not going to fail that vertical line test, so therefore it is going to be a function. So now let's look at domain and range. Domain is going to be the set of all the x coordinates, and the range is going to be the set of all the y coordinates. And it's just a way to think about what numbers exist, because in math, we like to classify numbers. It just makes math easier for us. And so finding the domain and range is basically a way for us to take a function and classify the numbers that it exists in and the different dimensions that we look at. So in this example here, if I wanted to find the domain and range of f, my domain would just be the x values. So -3, 0, 4, and 5. And then my range is going to be the y values, which happen to just be 1 and 2. Now notice 2 repeats itself. That's okay. You don't need to write it more than once. We just know that the range is going to be 2. Now, when we have a graph, what we're actually going to do is something called projecting. And so if the domain is all the x values, what we're going to do is we're going to project the graph onto the x-axis. And so projecting is like this idea of we're taking the graph and we're like pushing it or smushing it, or it's kind of a weird way to think about it, but it's like we're taking the graph and we're pushing that graph and we're flattening on the number line. Now, this process of flattening onto the number line, what it's going to do is it's actually going to create something that's shaded. Now, notice when I projected that open circle down, that also ended up with an open circle on the number line. And so now that I have this projection, my domain is actually everywhere that's shaded. So if I wanted to isolate that number line, so I just drew the number line here, I could say that my domain starts here at -infinity and goes all the way until I get to 1. And so this would be my domain. Now we call this interval notation, and we'll kind of talk about this throughout the class. I know we're not used to writing interval notation. That's okay. That's just something we're going to kind of table and we'll talk about later. Now for the range, we do the same thing, but because the range is the y values, we're going to project this onto the y-axis. So if I'm going to take this and I'm going to smush this onto the y-axis, we're going to get a number line. And so if I wanted to take that number line, and I'm kind of taking the number line and I'm rotating it because it's easier when I look at this, but just imagine this still being the y-axis. Once again, it starts all the way down here at -infinity and is going all the way up until we get to that value of 4. And so my range would be from -infinity to 4. Now notice with my interval notation, let's kind of go back. Open circle is going to be a parenthesis. Closed circle. So for this one, because it includes it, it's a closed circle. Closed circle, we signify that with a bracket. Like I said, we're not masters of the interval notation. That's okay. That's something that we're eventually going to continue doing. So let's just say if I wanted to find the domain and range of both of these. So I'm going to take all these values, I'm going to project it onto the x-axis. So I'll say the red, so I'm just smushing them on there, smushing them on there. So that means that my domain here is just the values of -4, -3, -2, -1, 0, and 1. Now my range, I do the same thing, but I want to project it onto the y-axis. So if I project it onto the y-axis here, project, 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 my range, I'm just going to list the numbers, so I get -1, 0, 1, 2, 3, and 4. So now on the next graph, project it, right? So I'm going to smush it onto the x-axis here, project it. I'm going to smush it onto the x-axis there. So starting from here is going to be from -infinity, and it's going to go all the way to -1. It includes it, so bracket. Now there's more, right? On this side, it's from 1 and goes to infinity. Now the way that we say that it's together, we use this symbol called union. So this is my domain. Now for the range, if I were to project this all onto the y-axis here, that's going to go from -infinity to +infinity. Because it's everywhere. It's shaded all the way down there, it's shaded all the way up there, and so that's going to be from -infinity to +infinity. So to close this lesson, what did we learn today? We talked about multiple things. We talked about a relation. A relation is just two things and how we want to compare them. The most common scenario that we do that is the x and y. Now there's a special type of relation we call a function, which for every x, there's only one y value that would pair with that. The next thing that we took a look at was going to be the domain and range, and the domain is just the set of all the x values, and the range was the set of all the y values. This does conclude our lesson. If you have any questions, please leave them in the comments.